This video presents the methodology used to analyze public transport accessibility in Greater Ipoh using GIS Pro. The first analysis was conducted to identify the spatial distribution of public transport facility in Greater Ipoh. The location of bus stop and bus terminal we add as a point feature. Different symbols were used to represent each type of facility. The result map shows the general distribution of public transport facility. The study area identifies area with high or limited number of facilities. Panel density analysis was conducted to identify the construction of public transport facility in Ipoh. The public transport facility point layer was selected as the Ipoh feature. The population field was set to none, while the output cell size was set to 50 meters and the distance radius was set to 500 meters. The area unit was set to the square kilometer and the planar method was applied. The result density surface was classified into 5 categories, ranging from very low to very high density. Distance-based accessibility was analyzed using the multiple ring buffer tool. Public transport facilities were selected as the input feature. Buffer distance of 400 meter and 800 meter were applied using the geodesic method. Areas with 400 meter were classified as having high accessibility, while areas between 400 and 800 meter were classified as having moderate accessibility. Location outside the 800 meter buffer were considered to have pure accessibility. Before conducting the travel time analysis, the road network dataset was prepared. A new field was created to calculate the length of each road segment in kilometers. Another field was created for walking speed with average walking speed of 4.8 km per hour. Travel time in minutes was calculated by dividing the road length by walking speed and multiplying the result by 60. The process road network was then used to create and build a network dataset. Travel time accessibility was analyzed using the service area tool in network analysis. Public transport facilities were loaded as service area facilities, while travel time in minutes was read as the network impedance. Walking time break of 5, 10 and 50 minutes were applied with travel derived away from the facility. Detailed service area polygon we generate using the recursion. Area with 5 minutes we classify as highly accessible, area between 5 and 10 minutes as a moderate accessible, and area between 10 and 50 minutes as having pure accessibility. Location beyond the 50-minute service were considered undeserved. World population data for Malaysia, we proceed to obtain population information for Greater Ipoh. The access by mass tool was used to clip the population raster according to the study area boundary. The clipper raster was deposited into the GS283 UT angle 47 knot. A cell size of 1000 meter was used, where each raster cell represented an area of 0.01 square kilometer. Population density was calculated using the raster calculator. The population value of each raster cell was divided by 0.01 square kilometer to produce population density in people per square kilometer. The resulting raster was then classified into 5 categories: very low, low, moderate, high, and very high population density. The output was used to identify area with large population in Greater Ipoh. By combining the travel time accessibility result with population density. Area located beyond the 50-minute service area were first identified as heavily limited access to public transport. These are areas where the overlap with high and very high population density areas and residential location. Then the tool was used to produce the final unreserved area layer. Areas with high population construction and limited public transport access were given relative priority. The identified unreserved areas were classified into low, medium and high priority categories. Low priority areas represent location with smaller population concentration. Medium priority areas contain moderate population concentration and limited accessibility. High priority areas represent densely populated for residential location located future public transport